So hi all, and welcome to my channel again. So today we are going to talk about one of the already talked about topics, which we have also discussed in the past, and that particular topic is uh, the RAG, or the Retrieval Augmented Generation, right? So what is RAG, right? So basically RAG is your Retrieval Augmented Generation, uh, and basically its job is to make an LLM answer using the relevant information retrieved from a external knowledge base. So basically it takes up the documents. The document is basically in any chunk, sorry, in any format, and then it reads the file. It split the text into the chunks. It then generate the embeddings, store embeddings in the JSON index. uh, Basically the user is capable to ask a question, and then it will generate the embedding for question. It will compare the question embedding with documents and retrieve the top relevant chunks. It will then send the retrieved context and questions to the GPT, and then it will generate the final answer, right? So that is how the existing code works, right? Now the first part of this is, so I have currently written over here somewhere around 11 to 1300 lines of code, right? And we are basically importing the OpenAI client over here, right? So you can see that there is a module used over here, which we have also used in the past to import the OpenAI, and basically your key will be the deciding factor to run this as a part of RAG. If you would see, in the past we have already discussed the RAG multiple times in multiple places, right? Whether it would be the Meraki MCP server or would be the AI agent, we would have talked about the RAG, and there is a specific session for RAG which I have already done in the past, right? So basically the env file that we have created, which we have also created in multiple uh, uh, you know uh, videos. So that env file basically is used to take the key, fetch the key, and then utilize that particular key. Now the OS provides the function for checking the files, working with directories, reading environment variables, handling file paths. So we basically import the OS module, and then we import the sys module, right? The JSON is the JavaScript object notification is basically used to save and load our RAG index. Our index will contain the source file, chunk number, chunk text, and embedding number, right? So uh, you can use a lot of things like rpass, and then you can run the chatbot.py file over here, right? So basically the name of my file is rag, so let me click over here, right? Or we can remove this because we are currently not putting anything as an argument, but yes, you can go ahead and put this as a argument, right? Okay. We can talk about the numpy. So numpy is basically used as a part of numerical Python. We already have a particular video that is dedicated for the numerical Python. It is used for converting the embeddings into the arrays, calculate the vector magnitude, normalize vectors, and calculate the dot product. It is also one of the most important concepts used in the machine learning, right? And then we have the optional PyPDF, because we will be using this to import most of the files that would be in the PDF format. Yeah, definitely we have other formats as well, and we have imported that, right? So you can see the doc support is there, right? Now basically our other formats are also supported, like the text format and all that stuff. uh, the main part over here is the the env file, where we basically import the particular key from the environment file, right? So it keeps your OpenAPI key secure. Uh, then we have created a JSON file, which will store a RAG index, and then we will use a LLM model to generate the final answer, right? So embedding model used to convert the text into the vectors, right? uh, Now these are the supported file index that we are using. You can see mostly all the files have been used, whether it is a text file, MD5, log, py, JSON, YAML, CSV, XML, HTML, PDF, and all such sort of files, which have the capability to be imported by this particular rack, right? So you can load the environment variables from your env or aenv file, you provide the path, read the OpenAPI key, and then you validate the API key as well, right? So now after that, on the ninth step, we create the OpenAI client using our API key, right? So this is basically the command to create the OpenAPI uh, client, which is client is equal to OpenAI followed by API key is equal to API key, right? So this is our API key, right? Now what it is going to do is it is going to read the text from the file. Once the file has been successfully read from the text, uh, so if there is any bad file or corrupt file has been provided, it is not going to halt the operation. It will open the file in the read code. It would study it in the form of encoding. It is going to ignore or prevent the program from crashing if the file name contains an invalid character, and then it is going to raise an exception error over here and proceed ahead, right? So it will display the file that is caused the problem, and it will return the empty text so the program can continue. Then we have created a function named as the read PDF file, which is going to read the PDF files, and it is going to help the RAG in creating the chunks so that later on we can put the answers from there. uh, once we create a PDF reader object, then it is going to iterate through every page in the PDF and extract the text from the current page. So some PDFs may not contain extractable text, and we can add the page text to our complete text file, right? So if something goes wrong, we can report the error and we can return all the extracted PDF text, and we can continue to the next phase of the program, right? So similarly, we have created the function to read the document files. uh, then this is a generic file reader to read everything, if a file is a PDF, if a file is a doc, and then for all the other supported formats, treat the file as a normal text, right? We collect the files from the folder. So basically there is a path that has been provided. So there the os.path, which is basically imported from the os module, will be used, right? And we will be importing the files from that particular folder. We will split the text into the chunks in the next part, and then we divide. So what do you mean by chunks, right? So we basically divide a larger document into the smaller pieces, so that is basically nothing but chunks, right? And the maximum number of characters in a chunk will be decided by the chunk size. So we have kept the chunk size to 12,000, and then the overlap, which is basically the number of characters shared between the consecutive chunks, right? So we make sure that the overlap is smaller and the chunk size smaller than the chunk size, otherwise your loop could behave incorrectly, right? So basically, point to remember over here is that the overlap should be less than the chunk size, right? So we create an empty list for chunks. We normalize the window style line endings, which is text to place /n or /r/n. We replace the remaining new lines with the spaces. uh, so we also remove the multiple spaces over here. So let's say hello and world are apart, so we will make them hello world with a single space apart. Starting position of our first chunk is going to be 0, and then we continue until we reach the end of the text, right? We calculate the end position, we extract the chunk, we only save the non-empty chunks, and then we move forward by the chunk size, uh, but move backward by the overlap, right? So we have the chunk size and we have the overlap, right? That's our safety check, and then we return all the chunks, right? The next part will be the function that we have developed is normalizing and embedding vector. We normalize, and which normalization basically converts the vector to a unit length, and then it allows us to use the dot product as cosine similarity, right? So we convert the Python list into a NumPy array, we calculate the magnitude or norm of the vector, and then we avoid division by 0. We divide every element by the vector magnitude, and then we convert the numpy array back into a Python list. The next part is creating embeddings, right? So once we create the chunks, then we have to convert a list of text chunks into the embeddings, and then each text chunk becomes a numeral vector, right? So we instead of sending every chunk separately, we process the chunks in batches. We iterate over the text list in batches, select the current batch, display progress to the user, and then we call the OpenAI embeddings. We select the embedding model, and then we send our current batch to text. Then we iterate through every embedding returned by OpenAI. Right. After that, we will start building the RAG index. The RAG index will read all the files. It will create chunks. It will generate embeddings, and then it will save everything into a file called as a RAG index.json. Right. It will display which folder we are indexing. It will find all the supported files. If no files are found, then there is nothing to index, right? And it will not be able to give the answer that we are going to see as a part of the demo in this later part of the RAG, right? And why it is used. So now this list will contain all the documented chunks. It will process every file. It will display the file being read. It will extract the text from the file, ignore files which are not readable. It will split the document into the chunks. It will enumerate and give the chunk number and the chunk. It will store metadata along with each chunk, and then this metadata will be extremely important because later we would want to tell the user which file produced the answer. And then the chunk, it will check whether any chunks were created or not, right? So that is the part of this is the most interesting part, where it fetches everything from the document, and if the document is not present, it will not be able to provide you the answer. If something is present, it will be able to give you the answer. So that is what the RAG is all about, right? If it has the information, it will provide you. If it does not have the information, or if you have not trained your model through the RAG, then unfortunately it will not be able to give you the answer, right? Now we can convert our Python objects into the JSON. We save the index, and then we tell the user where the index was saved, and then we return the complete index, right? So that is like giving the answer. Yeah, so load an already created RAG index from the disk. Check whether the index file exists. If no index file exists, then you return none. Open the JSON index. You convert the JSON back into the Python objects, and then you display any loading error, right? You retrieve the chunks, create the embedding, you extract the actual embedding vector, you normalize the question vector, and then you convert the questions embedding into an numpy array, right? You compare the question with the documented chunks, and then based on the similarity, so you convert the store embedding into a numpy array, and then you calculate the similarity, because both the vectors have been normalized. The dot product is equivalent to the cosine similarity. Now you store the score and the metadata, and you sort by similarity. So you sort the chunks from higher similarity to the lower similarity, and then you return the top k chunks. Now this is the part where we the code we have seen in the past, where we ask RAG about the questions, we retrieve the answers, we create an empty list to hold the formatted context blocks, and then we every retrieved chunk will be put up to the context, right? So it will create a readable context block. You will have the source, you will have the file name from where the answer was belonged, you have the chunk, and then you have the content, right? So okay, fine. So the system prompt defines how our RAG assistant should behave. We'll put up the prompt. The call will go to the LLM. The LLM will use its chat model. It will extract the generated answer, and then it will return both the answer and the retrieved chunks. And we return the chunks because the main program will display their similarity scores and sources, right? So this is the main function from where your entire code would operate. So let's run it now, right? I will not waste a lot of time, but I will go ahead and run it. Let me run the module. We are waiting for the RAG to start. Okay, so let's say I want to talk about HSRP for IPv6. So you can, let me show you over here. This is the interesting part. Now I have a file, but it is not at the location which I have pointed it to, right? So I'll tell you, okay, hi, uh, do you know about HSRP for IPv6? Let's see what is the answer. Right, so it was not able to find this information in its index folder, right? So because it's not having any answers, it won't be able to provide you one, right? So let me, you can see that it is trying to find the answer from a particular directory, right? So this is particular directory. So let me, copy this file, because its file is this file is at a different location, and I will go to the place, from where it is fetching the file, right? So this is the RAG, this is the file that I've created, and let me paste the file over here, right? So I've just simply copy pasted the file, right? Now let me close this and rerun this again. Okay, so I want to kill it. Yes. Now let me run it again. Okay, so now it is going to read that particular file, right? It has loaded the existing index, right? And just give me a moment. Right, so let me talk about, do you know about HSRP for IPv6? Let's see. Okay, so it's not able to find about it. Let us do one thing. Let us ask it to rebuild it, right? It is basically loading it from the existing index, right? So let me kill that stuff, and let me delete this as well. Okay, so I'll delete this. Yes. Now let me run this again. Now you can see that while it is creating the JSON file, it was able to successfully read the HSRP for IPv6, right? So during the previous run, anyways, I apologize that I was able to copy the file over here, but the file was not read because the index.json file was already created. Now if it is already existing, it won't take the new file, and you have to sort of delete that JSON file and create the JSON file again, right? By rerunning the program. Now you can see that the total number of chunks created are 53, creating embedding for 1 to 50 or 53, 51 to 53 or 53, right? So now I do you know about HSRP for IPv6? Give me some information. Let's see. So it has given me some key points about the HSRP, the protocol version, the virtual literacy, the configuration, the priority and preemption, authentication, and it was able to provide me a lot of information, which is a good information about HSRP, right, for the IPv6. Now let me ask it a question about the IP routing, right? So let me talk to it and ask the questions about the IP routing. Now you can see, since it is loading the existing JSON file only, that is going to cause a problem, right? Because it is loaded the existing index from the RAG index.json, so that has to be deleted every time we power on the or we run the script, right? So if I talk about it like, can you explain IP routing? Let's see. no, it is not able to explain the IP routing. So what we are going to do is we are going to kill this uh, run, and then what we are going to do is we are going to go back and we are going to copy another file from the IPv6, which is basically the for not for the IPv6 but generally for the IP routing, right? So let me check if we have the file. Okay, okay. So I have the IPv4 file over here. Let me copy it to the RAG also, right? And we will delete the RAG index.json. So I'll delete it, and then we can start working on this again. Now let's rerun it. You understand that last time we did not receive any answer for the IP routing. This time we are going to talk about it again, right? So now you can see that the JSON would have been populated with both the PDF files, which is the HSR for IPv6 and IP routing explained.pdf, right? So now let's see how it goes, right? And some CLI commands, because I'm quite sure that this PDF file would be having a lot of CLI commands, right? Okay, let me talk to it again. Yeah, so now we can see that it has provided us with the information on the IP routing. Various codes used in the IP routing table such as L, connected, static, the rep, mobile, PGP, AGRP, OSPF area, right, ISIs and others. And the routing table shows that is directly connected to this one interface, is also connected along with the specific. So it has basically read that particular PDF files. It was able to uh, go ahead and first it was able to read the file, split it the text into the chunks, and whatever information it got, it generate an embedding. It stored the embedding into the JSON. So once the JSON was created, we asked it a question, and then based on whatever information it had in the IP routing information, it was able to provide it us, right? You can even train it in a networking, even in a much better way, where it goes ahead and it reads a very large file, and then it can ask question like, so let's say I have a routing and switching book which is in a PDF format, which is valid and purchased one, and then you can convert it into you can put it into the PDF formats. Then this program will split the text into the chunks. It will generate the embedding. Be careful to delete the previous JSON file and then let it create a new one. And then you ask it a question. So based on the embeddings generated for the question, it will compare the question embedding with the document embeddings, and then it will retrieve the top relevant chunks and it will retrieve the context. So now see, the answer to the question cannot be up to the mark, but if you would keep your prompt up to the mark, then maybe you can get the right answer to the right question, right? So yeah, and that's RAG in action in 1300 lines of code built from the ground up. No magic, just retrieval, context and generation working together. So if you want to see how every component works under the hood, then you subscribe and stay tuned for the next video. I will also post the link to my GitHub, where you can go ahead and you can see the RAG file, and you can also go through the readme.md file, which will provide how the things have been done and what was the architecture, how it was retrieved, and what all and what not I have used over here would be available in this particular format, right? So I would thank you, or I would like to thank you for viewing this video, and I will see you into the next video. Thank you so much.